Everyone, myself Sagar M. Nayak, working as an assistant professor in Bhagwan Mahavir College of Engineering and Technology in Civil Engineering Department. Today we discuss about a singly reinforcement beam. So before proceeding further, first of all we understand what do you mean by beam. A beam is a structural element that designed to carry transverse external loads. The loads that cause bending moment, shear force and in some case torsion across their length. Thus, steel is provided to take tensile stress in RCC beam. Generally, there are four methods of design of a concrete structure. First one is working stress method, second one is limit state method, and third one is ultimate load method, and fourth one is probabilistic method of design. So as per syllabus point of view, we just discussed about the limit state method of design. So limit state method means it is a method which considers the ultimate strength of material at failure and also assure that structure is serviceable for its intent period of design. Limit state method comprises of two main points. First one is limit state of collapse and limit state of serviceability. Further, all loads that are reliable to act means the load which include dead loads, live loads through its life, and it should also be satisfy the substability requirement such as limitation on deflection and cracking. It holds also be able to maintain the required structural integrity during and after accident such as fire, local failure, explosions, etc. That is, limit state must be considered in design to ensure an adequate degree of safety and serviceability. The most important of these limit state which must be examined in design point of view, that is flexure, compression, shear and torsion. Now let's go to a main topic. Generally there are three types of beam: singly reinforcement beam, doubly reinforcement beam and a singly or doubly reinforcement flange beams, or we can say a T-beam. So what do you mean by singly reinforcement beam? A singly reinforcement beam is that type of beam in which a steel is provided only in tension zone only, so to provide a strength to the structure. Here is a typical images of a beam in which, as we can see, a steel is only provided in tension zone only, that is lower part, to provide a strength. Now here is a stress strain diagram of for singly RC beam as per IS 456-2000 page number 69. So the minimum strain as per IS code 456, it should be 0.0035 and a minimum tensile strain is equal to 0.87 Fy by ES plus 0.002. Now here what do you mean by X? Where X is equal to depth of neutral axis. So what do you mean by neutral axis? Neutral axis is that axis which divide a beam into equal parts, that is compression zone and tension zone, where B is equal to breadth or width of section, where small d is known as effective depth of section, and XU max is equal to the maximum depth of neutral axis. The depth of neutral axis can be obtained by considering the equilibrium of normal forces, that is resultant force of compression and the resultant force of tension. The resultant force on compression is equal to 0.36 FCK B into XU, which is equal to resultant force of tension, which is equal to 0.87 FY80. From that we can find out the formula of depth of neutral axis, which is equal to XU is equal to 0.87 Fy80 divided by 0.36 FCKB, which is given in IS 456 at page number 96. So first of all, what do you mean by FCK? FCK is known as the characteristic strength of concrete. Means, for example, if we are using M20 grade concrete for design, where M means mixed design and 20 stands for the characteristic compressive strength of concrete at 28 days of curing. Now what do you mean by Fy? Fy is known as a tensile steel grade of steel that we used in design of structure. Now maximum depth of neutral axis. A compression failure is a brittle failure. So to ensure that the tensile steel will reach its yield strength before concrete fails in compression, hence to avoid a brittle failure. Generally, there are two methods of finding out the maximum depth of neutral axis. One is from stress strain diagram and another one is that is given in a IS 456 2000 page number 70. For example, if we use Fe 250 grade steel, then the maximum depth of neutral axis is equal to 0.53 D, where D is known as effective depth of the section. For example, if we use a 415 steel, then it should be 0.48 D, and if we use 500, then it should be 0.46 D. Now, generally, there are three types of section: balance section, under reinforcement section, and over reinforcement section. If depth of neutral axis is equal to the maximum depth of neutral axis, then it is known as balance section, and if depth of neutral axis is less than maximum depth of neutral axis, then it is under reinforcement section, and if depth of neutral axis is greater than maximum depth of neutral axis, then it is over reinforcement section. So first of all, what do you mean by balance section? Balance section is a section in which the tensile steel reaches yield strength as concrete reach failure in strain, which means concrete and steel will fail both at the same time. Now in under reinforcement section, tensile steel reach yield strength before the concrete to reach failure in strain, which means steel will fail first, then concrete. And over reinforcement section, in which concrete reach strain earlier than a steel reach its yield strength, which means concrete will fail first, then steel. So as per as structural designer point of view, one must go through a under reinforcement section because it shows a sign of warning before failure, so that we can take a necessary precaution. Generally, there are two types of problem that we have to learn. One is analysis of the section and second one is design of section. So in further video, we should go through analysis problem and design problem as per IS 456 2000. Thank you.